Hello, class. This is Mr. Hart, and in this podcast, we want to finish up the volcanoes chapter of our textbook. Last time, we looked at the types of volcanoes that we can have. In this podcast, we want to look at the different states of the volcano. Okay, so a volcano can have three different states that it can be in. Okay, first of all, it can be active, meaning it's currently erupting or showing signs of erupting soon. Okay, so it has the magma chamber, it has the large amount of pressure buildup. It could go off any minute, or it can be like Kilauea volcano, which is just constantly erupting magma slowly and lava to the surface. Okay. It could be dormant, meaning there's no current activity, but it has erupted recently. Okay, like Mount St. Helens currently is dormant. Okay, erupted in 1980. So there's not currently activity, but has erupted very recently. Okay. Or it can be extinct, meaning there's no activity for a long amount of time and it probably won't erupt again. Okay, a lot of cinder cones are extinct. Okay, the other islands of Hawaii, except for Kilauea, are extinct because the hotspot has moved away. They no longer have magma chambers underneath them. Okay, so it can be either any of those three states. Okay, active, dormant, or extinct. Okay, a lot of people use dormant and extinct interchangeably. Okay, in the popular culture, popular text, right? We just kind of switch those whenever you want, okay? But they do have two different meanings, okay? Dormant volcanoes do have the possibility of becoming active again, right? They could have a magma chamber that builds enough pressure again to start erupting. Whereas an extinct volcano probably will just never erupt ever again because it just doesn't have the magma chamber and the pressure that it needs to erupt, okay? So just keep that in mind. We sometimes use them interchangeably saying, oh, that's dormant or that's extinct, okay? But they do have slightly different meanings. Okay, so active, dormant, extinct. Make sure you understand the differences. Okay. Next, there's a couple of vocabulary words we want to make sure we understand. I've kind of mentioned them as we've been going through, but let's make sure we understand for sure. So the first word is a pyroclastic flow, which is that fast-moving current of rock and gas, that cloud of debris that moves after a explosive eruption. Okay. There's the caldera, which is that bowl that forms at the top of the volcano after a volcanic eruption. Okay, kind of sinks down underneath, creating a bowl shape. There's a fissure, which is a linear volcanic vent through which lava erupts. Think of Iceland, those line volcanoes that split apart as the divergent plate boundaries move. Okay, and then we have geysers, which you probably have heard of before, which is just that water that is superheated by magma and erupts through a narrow passageway to the surface. Okay, just think of Yellowstone, think of Old Faithful. That's a geyser. Okay, so let's look at each one of these individually. So with a pyroclastic flow, again, it's that huge cloud of debris and material and magma that is moving through from an explosive eruption. Okay, very dangerous. These can actually move very fast. Okay, a lot of the destruction from Mount St. Helens, for example, or Mount Vesuvius, a lot of these famous eruptions was from these pyroclastic flows that just move through and destroy everything. Okay, so again, don't think that these are nice and fluffy clouds. Okay, these are very dangerous, very deadly flows. Okay, the next thing was the caldera. Okay, this is a picture of Crater Lake in Washington, by the way, and it's actually the caldera of a volcano. If you can imagine underneath here, you can imagine the bowl shape that was created from the volcano. So this lake's actually at top of the volcano. Water is just filled in its space, okay? But the caldera is that bowl at the top of the volcano. If you've ever cooked rolls, for example, of any type of baked good, you can imagine after it has rised, or however you say that, okay? After it has rised and it makes a nice shape at the top, right? If you've ever poked a hole in a roll after it came out of the oven or a pastry or anything like that, it deflates, okay, because there's no longer air to keep it up. So the volcano does the same thing. Once there's no more magma in the chamber, okay, to fill in this space, then it kind of deflates. It goes down until it sinks back down to the bowl shape because there's no magma to fill in that gap, okay, and there's nothing to fill in that space, so it just collapses on itself. So just imagine a roll deflating, okay, or something like that, but that's what causes the caldera. This doesn't have any material to keep the shape up, and so it sinks back down. Okay. We have the fissures. Okay. When we have the divergent plate boundaries, okay, where magma comes through in a line instead of just in one single spot. And so we get these lines of eruptions, this line of magma flow. Okay. That's a fissure. And last of all, a geyser, which is just superheated water that explodes. Okay, if you've ever had a pressure cooker, okay, or your mom's baked something or cooked something in the kitchen and uses a pressure cooker, you've seen that you have the pan, right, with the handle, and you have this little knob at the top. And if you've ever looked at those, there's constantly steam coming out of the top of that pan. Okay, that's because there's pressure building up in that water, okay, as it's being superheated, and it can't keep all that pressure, so the steam has to escape to release the pressure. Okay. Well, if you ever watched a geyser, it's the same thing. Instead of with a pan and a stove, you have the water on top. You have a water chamber. Okay. So you have some underground water, an aquifer or something like that. Okay, and then you have the magma chamber underneath. So the magma acts as a heater, basically, a stove for the water. And so it's just going to superheat the water. The water is going to build up pressure, okay, and it's going to generate a lot of steam. So if there's an opening in the surface, okay, a geyser, then that steam is going to come out of the geyser, okay, and come to the surface. Okay, so if you've ever watched a geyser, generally there's just steam coming out of it all the time. If enough of that pressure builds up, then you can get a large explosion like at Old Faithful or something like that. Okay, but keep in mind this water is very, very hot. Okay, you wouldn't want to touch it. It's just been superheated by magma. Okay, but that's what's happening. The water's heating up. It's generating some pressure, and eventually it causes an explosion of water that comes out to release that pressure. Okay. But again, this does not count as a volcanic eruption because there's not magma that goes with it. Okay, there is magma that is causing the heat to occur, but it is not going with the water itself. Okay. All right. So those are 4 terms we want to know. The last thing we want to know, make sure we understand for this class, is we want to know a couple of cases of famous volcanoes. In class, we've watched a couple of documentaries about these volcanoes, but I just want to make sure you understand and kind of remember some of these famous ones. Okay. The first famous volcano that you should be aware of and know is Mount Vesuvius. Okay. It is the famous volcano that buried the city of Pompeii. Okay. Back in 79 AD in Italy, or what was then considered the Roman Empire. Okay. And so it's a very famous volcano because it buried an entire city. We still have remains and preserved bodies from that eruption. So that's very cool. Krakatoa is another famous eruption in 1883. It was in Indonesia when it erupted. This explosion was so large it actually blew apart the volcano, and we now have a child volcano of Krakatoa, which we call Krakatau. And so it's just famous because of the size of the volcano. It's probably the most dangerous volcano to erupt. Fortunately, it's pretty far away from other islands, so it can't do too much damage, but it's still very deadly. Okay. And the last one is Mount St. Helens, which is very famous because it was back in 1980, which is very recent for volcanic activity. Okay, and we have used this eruption as a means of studying volcanoes. We've learned a lot about volcanoes and how to predict them from the eruption of Mount St. Helens. We've been able to do a lot of analysis on that eruption. Okay, and so just make sure you are familiar with these 3 different famous volcanoes. Probably the most famous volcanic eruptions in history are these 3. So just make sure you know those and are familiar with those eruptions. Okay. But that is it for the volcanoes chapter. Let me know if you have any questions, and thank you for watching.